BotNet is a network of computers that has been taken over, infected by malware, and taken over by the writer of that malware. This network of bots is then used to collect information or to attack, create distributed denial of service attacks against targets, or collect information from the BotNet users themselves. Within BreakingPoint, we have a number of built-in BotNet test devices, and this one is actually a strike. This is a built-in test called SpyEye BotNet that uses a strike that is called SpyEye BotNet. SpyEye is a major botnet that was running about 6 or 7 years ago, and up to just a few years ago. And the owners of these botnets actually sell their services to people who lease the botnet for their own purposes, for attacks. I'm running this strike, and then we're going to take a look and see what it does. What this strike is going to show you is an example of command and control messaging between a single bot and the command and control server being run by the person who wrote SpyEye. So what you're actually going to see is a single session in a PCAP file. I want to bring that up, but first I want to take a look at the flow diagram of this command and control communications session. Let's take a quick look. We won't go through everything here. The basic idea is this is a check-in sort of session where the bot contacts the command and control server and then starts querying for information. Path names, for example, a path to a new build if there's a new version available for it, or a path to a new configuration that needs to be set up. It is going to turn on multiple plugins that might be already built into the malware that's on this infected system. The bot is the infected system. The command and control server is the person running the botnet. This all culminates in a post back the other direction to the command and control server. With the post will have stolen information, credit card information perhaps, or some other information that the command and control server wants to use for nefarious purposes. So in this PCAP file, the infected computer is 45.138. The command and control server running the entire botnet is 162.197. And again, we're examining communications between a single bot and its command and control computer. So this will consist of a number of HTTP GET commands where it's asking for some information. The bot's asking for information. The bot checks in with the command and control server and then says, give me this information, and they give me that. And this information is sent across the link. So, for example, it's asking for a path of any new builds. As time goes on, these botnets controllers, the malware is improved, and you get new versions of it, and this distributes these versions out to the field, out to the bots that are under control. So what we see here is in this 200 OK going back to the bot, you see a path to where the executable is located. And following that, the GET command actually goes to that same path and says, give me this executable. And the executables and binary files are all sent across in these broken up TCP packets that have maxed out at 1514 bytes. Back to this diagram, each of these dashed lines is a binary file or some executable that's being sent across as a result of a GET command going to the specific path where the file is located. So what happens next? We've got the new version of the malware. The next step, we're asking for a new path, and then the next GET command uses that path, and it's a config.bin file. And as we slide down, further down, what we're going to see is the next get command. Now this one is asking for basically flag settings. It's asking for status of the different plugins. And if we look at the 200 OK coming back from Command and Control to the bot, is turning each one of these plugins on. So CC Grabber, that's a credit card grabber. Billing Hammer is actually something that takes credit card numbers that the bot has taken from its owner, the computer's owner, the laptop's owner. This bot's taken credit card information, if it has stolen any, and it uses that credit card information to go out onto the internet to fake stores where it's going to buy things over and over, like buy stolen software. And the credit card then is going to see these purchases and not know that they're fake and send money to the proprietor of this fake store. The people that create bots like botnets like Zeus and SpyEye actually set up their own set of stores for people that borrow their botnets that buy services from them to buy stuff from using this billing hammer. That's just, there's so many different things that bots can be used for. I'm going to jump a little further down, and again you see a path being asked for, and this time this is a loader file that it's asking for. You see the load, and the loader file is going to be used for installing the software and the configuration file that have been recently downloaded earlier in the session. So you see the path is received here, and then I'm going to do a get. The bot does a get, and it goes to this same path that it just received from the 200 OK, and it downloads the loader. We get it again in this series of fragmented TCP packets and or PDU, and then what's the next thing that happens? Now we give it, through the get command, the load complete message, and so now the command and control computer knows we're done. Bot has everything it needed, and the next thing that happens, and it knows what comes next, is the post command. And the post command is sending the command and control computer all of the information that it's gotten, credit card numbers, any other sorts of information that it's stolen. All pertinent information is now headed back to the command and control computer. The post command ends the session. The final message coming back is at 200 OK, and it has 0 and as its payload, and the session is done. So this is a single bot communicating with its command and control computer. You go out there, and some of these botnets have been recorded as being 3 million computers large, and that's the largest one known. And so these botnets communicate with their command and control computers, but because law enforcement has found ways around some of this, for example, tracking down the owners of the command and control computers, a lot of new tactics have been used. For example, there might be a proxy between the command and control computer and all of the bots. Furthermore, you might use anonymous networks, the Tor network, for encrypting all the communications between these computers. And on top of that, you have peer-to-peer communications between the bots that replaces what we just saw here. Instead of going directly to command and control, many of the bots send this information back and forth between them. They create sort of a mesh network, and only a few of the bots actually communicate back to the command and control computer. And so the new versions of the malware, or new commands, new campaigns, configurations are sent through the mesh via peer-to-peer communications that will look a lot like this, but they'll simply be between two peers, two bots, but it still originates back at the command and control computer. All of these are used to make it harder and harder for law enforcement to bring down these giant botnets. That's the latest, folks. So I hope you found this enjoyable. Stay tuned for my next video.